Record, and we'll get going. Welcome, everyone. Wow. Thanks for spending your Thursday evening with me. Like I said to some folks before everyone arrived, like obviously Thursday evening, not ideal after a long day in the classroom or whatever it is you were doing today, but I wanted to make it a time where people could attend if they were interested, and we'll record this and send this along to folks who weren't able to make it with us this evening. But yeah, really, thank you for joining me. It's really nice to see so many familiar names and faces. So for those of you that have worked with me in the past, a lot of this will be familiar, which is great. The resources look very similar across the board. So hopefully, given that you're familiar with my structure and the way things look, you'll be able to pick up some of the moves that I'm trying to communicate here. So what we've got here, data puzzles. What is data puzzles? Data puzzles is this data analysis resource that I've been working on and off for about a year, and it utilizes ambitious science teaching practices to help students make sense of science phenomena. And so tonight we're going to be engaging with these ambitious science teaching practices in the context of this is kind of my latest data puzzle resource called Tracing Carbon Through the Arctic Food Web. And so students are going to be tracing carbon through the Arctic food web to predict how changes in sea ice, declining Arctic sea ice, might impact Arctic organisms that are large and small. So that's the goal of this resource. My goal tonight is to hopefully guide you through this resource and provide you with enough strategies that you feel comfortable when you leave here, comfortable and confident to utilize this resource in your classroom if you so choose. And also we'll sprinkle in a little incentive, and that is if you are interested in utilizing it this spring and providing some feedback to me, we can offer you an Amazon gift card in the order of $50. There are some people in this group that I owe money to right now, Margie. And that is not lost on me. And I had a meeting about it today. It's just taking the university a little bit of time to approve that gift card, but I was assured that the gift card would go through. So Margie, I've been thinking about you. So that incentive is there should you choose to do that after this webinar. We already talked about breakout rooms. We're not going to do them. So without further ado, we'll get started. Many of you already know me. My name is John Griffith, and I'm a curriculum developer for the CERES Education Outreach Team. CERES stands for the Cooperative Institute for Research in Environmental Science. It's a program within the University of Colorado Boulder, and where we work with scientists at the University of Colorado Boulder and scientists at NOAA, and our job is to communicate their current research to K-12 classrooms by developing hopefully innovative curricula. Joining me in this project is my supervisor, Dr. Anna Gold, and want to acknowledge some really important collaborators that are working with us on this project. Perhaps most notably and most closely, Dr. Melissa Bratton, who won't be able to join us this evening. She's doing some PD with Denver Public Schools today. She's an assistant professor in the School of Ed at CU Boulder and a co-author of Ambitious Science Teaching. So it's been really nice to have her obviously on this project to kind of help guide some of the moves that we're trying to embed in this resource. Also involved is Dr. Carrie Wingert. She's a curriculum designer for Inquiry Hub. Perhaps some of you have heard of that. That's a storylining type group affiliated with Open SciEd. So they develop storylines for high school curriculum. So this is our team, and I think what makes us really excited about this resource, among other things, is we are at CERES are connected to 800 plus scientists at CU Boulder and NOAA, and so we're excited if we can get this framework nailed down and produce a product that teachers like. It feels like we have access to a lot of data sets, and coming from a classroom, former teacher, an 8th grade science teacher, I know it can be really hard to find those curated, neat data sets for students. And so hopefully we can provide those data sets in this prepackaged form for teachers. Story behind this resource, and many of you here already know, you've heard this song and dance. Like when I was hired in 2019, I was solely focused on creating resources related to the 2019-2020 Mosaic Arctic Research Expedition. And so really focused on connecting classrooms to this expedition through virtual reality tours and development of curriculum. And when I wrote a few of these units, I was like, wow, there are some really important data sets that are kind of buried in these units. And if teachers aren't going to use these units, they might not find these data sets. So things like long wave, short wave radiation, albedo, sea ice extent, many of the data sets that you've all come to be familiar with if you've engaged with PD or resources I've developed in the past. And so after the field portion of the expedition ended, we were trying to figure out ways that classrooms could continue to connect with Mosaic and continue to follow the expedition by using authentic data. And so we reached out to our friends at Data Nuggets to produce a data nugget, basically, a story about the scientist Jen K and how she collected these data sets and what they might mean. And so you'll see a lot of elements of data nuggets in our data puzzles, but we really felt like we wanted the flexibility to incorporate some of those contemporary teaching practices in our data analysis product. And so we've modified data nuggets. We've taken some things from Daily Do's, NSTA Daily Do's, if you've heard of that resource, tried to weave in some of these ambitious science teaching practices. And the result is this data puzzles product. So for those of you that might not be familiar with this ambitious science teaching, these practices, it's a pedagogical framework with principles, practices, and tools to support the meaningful and equitable science education. And so this is a snapshot, an image of the framework as it's presented in the Ambitious Science Teaching book. And you'll see that we've modified this framework slightly with co-author of the book, Melissa Bratton's permission. This figure is really representing like an educator planning a unit or a lesson to incorporate these practices. And in our case, we've already planned the lesson, the unit, to incorporate these practices. So you'll see that we've moved some of these quadrants around. In the top right, if you were planning for this lesson, you're planning for engaging with important science ideas, trying to think about how to connect science ideas in a cohesive, coherent way from the student perspective. Really important to elicit student ideas about key resources, about key science ideas. It's helpful for sense making. Spend a lot of time thinking about this in terms of creating equitable resources. How can you utilize student ideas, experiences, and language as resources to help them make sense of new phenomena? So really want to pull those ideas out, and you as the facilitator keeping track of them either in your head or in public records, and use those as resources throughout the data puzzle and throughout your instruction if you're incorporating these practices. Working with students to support ongoing changes in thinking, and then pressing for these strong evidence-based explanations. And in the case of data puzzles, a conceptual model to demonstrate new understanding. So these are the ambitious science teaching practices. And we'll skip breakout rooms. And so in data puzzles, the way that we have embedded ambitious science teachings, more or less, we've flip-flopped the orange and the green box quadrants here. So rather than starting with the important science ideas, right, we're going to start with student experiences first. And this was really important in the development of our first few data puzzles when they were focused on the Arctic, right? We didn't want to take students like directly to the Arctic, a place they had never been, largely probably never thought of, and start talking about concepts like albedo without providing some context and giving them an opening scenario that they might be able to connect to, right? So we didn't really want to scare them off right away. We wanted to bring out their experiences maybe about albedo without using that term. So this eliciting student ideas page, it's that or practice is to help students connect to the scientist's research by eliciting their ideas about a similar or related event or scenario. So once we've pulled those ideas out, then we're going to go into the text and watch some videos and maybe engage with a virtual reality tour to help the students connect to the scientists and their work through interactive readings that include visuals, guided questions, and an investigative question that students will make predictions for. A key piece here is that we're going to try to help students connect their experience to the important science ideas that are introduced in this interactive reading. Once students have identified this investigative question, they've made an evidence-based prediction based on the text that they've read and the visuals and videos they've interacted with. They're going to test that prediction by analyzing and interpreting an authentic data set. And then the goal here at the end is that they can gather or piece together evidence from the interactive reading, from that data analysis piece to construct a final explanatory model for the scientist's investigative question. So these are the ambitious science teaching elements and how they're included in these data puzzles. Tonight, we're going to focus on this tracing carbon through the Arctic food web data puzzle. This is a data set that I've extracted from a larger unit that I've written. It's called the Changing Arctic Ecosystem. I'll put a little plug in for that, and I'm running a PD on that this summer that you get a credit for if you attend. But it's a little bit of a work in progress right now, but this was a data set I was really excited about from the unit, and so I wanted to pull it out and put it into a data puzzle. Before we dive into the data puzzle, I wanted to first just take us to the website. This is the data puzzles website for those of you that haven't been there. I'm going to add this to the chat. And I wanted to just walk you through what the teacher guide looks like. And for those of you that are familiar with my work, it should look pretty familiar to you. So I'm going to dive into this tracing carbon through the Arctic food web. And here's the teacher guide. And so like other teacher guides that you've seen from me, if we've worked together in the past, there's a little bit of background information about the resource at the top. Then a lesson overview. These data puzzles, they really do take 2 days because we're trying to make this a collaborative learning resource. There's going to be discussion, there's going to be student disagreement, and with the discussion, and we all know when students are making graphs and analyzing graphs, that takes time, right? We don't want to rush these different parts, and so this does take 2 days. And so the parts, I've labeled the parts here and how long I think they will take. The name of the parts just is the ambitious science teaching practice. So kind of keeping track of where those practices are coming into play. And then the second page, the instructional overview table, connection to different standards, questions, what students will do in the materials. We've got a slide deck, student worksheet, answer keys, vocab, and then the parts described in greater detail. New kind of fun thing that we've added to the teacher guide, a little pedagogical pop-up. That was Melissa Bratton's alliteration, play on words that we thought we'd put in there, and really just want to highlight the goal of each of these parts. So the goal of part one, right? We want to draw out student experiences and student language about an opening scenario, something related to what students will read about in part two when they're identifying important science ideas. So in this teacher guide, we've got all the links to different videos and visualizations that students will be engaging with in the different parts. And then at the end, something a little bit different than in teacher guides that I've created in the past, created an additional teacher resources and extensions piece. Added this because when I do research for these data puzzles, I feel like I find a lot of cool things. And so I want to just include them here. So if you are excited, if your students are excited about something that comes up in a data puzzle, maybe you can find it in that additional resources section and run with it with your students. So that should look pretty familiar to you. The slide deck, there are speaker notes that you should pay attention to, the student worksheet. One really important thing, and I'll bring this up again here in a little bit when we engage with it, there's no opening scenario in the student worksheet that's meant to be facilitated through whole class discussion or a couple of other facilitation strategies I'll mention. But there is, like in a data nugget, there's like some text at the beginning that students would read either individually or as a whole class. We've got some pause and play sections here where there are videos or little data visualizations that students could watch on their own or as a whole class. Some different graphics, and more videos. So things like, what's different about this relative to a data nugget is there are some of these resources embedded in to help give the students some more background information, specifically like highlighting important science ideas that they'll utilize later on in the resource. So I'll add this to the chat in a little bit, but wanted to just draw your attention to the teacher guide and again the resources that are provided for you as part of this resource, as part of this data puzzle. So without further ado, let's get into it. So we're going to be looking at the actual slide deck from the data puzzle and skipping through a few things. But in the past, when you have attended a workshop with me, when I'm facilitating and when we're looking at slides, there are only a few slides out of the larger unit because I'm just trying to highlight key points. With this, I've included all of the slides that are included in this particular data puzzle. This is a teacher-facing slide, not included in the slide deck. Just wanted to highlight. So we're going to be engaging right now in this eliciting students' ideas practice. And the goal here, again, is to elicit student ideas about an opening scenario, whether that's an image, a video, or a demo that has similarities to the science investigation presented in the data puzzle. So again, really key here to draw out student experiences, ideas, and language that could be used as resources to help students make sense of the phenomena they'll engage with in part two. So like I said, this part is not included in the student worksheet. And it's one that you may want to skip, but it's a really important piece to the data puzzle. I didn't include it in the student worksheet, largely for the aesthetic purpose, and didn't want to make it too confusing about what's happening. So this eliciting students' ideas, this opening scenario piece, you could utilize this as a warm-up prompt. If you're doing a warm-up every day in your classroom, have students respond to the opening scenario as a warm-up prompt, or some sort of think, pair, share. We've had teachers facilitate this particular data puzzle utilizing whiteboards and small groups. So however you want to facilitate this, we'll leave that up to you and what your classroom norms are, but wanted to just offer a few different strategies for you. In the chat right now, if you could respond to the following opening scenario prompt. And that is, what does it mean when someone says you are what you eat? So this is the actual slide that's included. We're in the slide deck now for this resource. This is the opening scenario that will ask students, what does it mean when someone says you are what you eat? Awesome. So really great things coming out in the chat. And this is what will happen with your students. You're going to get a range of answers. So quality of food determines your health. And then we've got some really different words, like we're made up of carbs, proteins, lipids. So different kind of words are coming out. Body absorbs molecules. So we're getting molecules. Looks like these are kind of the molecules we're getting from the food. Quality of food affects your health. What you eat becomes building blocks for growth, repair, cell function. I get my energy from food and requit. DQ Blizzard, there we go. That's kind of what I'm thinking. I'm expecting lots of like hot Cheetos and Takis talk, and saying like Takis are part of, you know, the main food groups. So nutrition and health. So lots of really cool, really important ideas here, right? And so if you're facilitating this, maybe you're writing some of these ideas down on a piece of butcher paper. Maybe probably what I should have done, maybe you're doing a Jamboard and students are responding to this on a Jamboard. I know a lot of you use Pear Deck as well, so maybe you're using a Pear Deck here. But again, looking at this, you can see there's lots of different words. You're going to have students talk about different foods they eat. So just pay attention to that as a facilitator and try to utilize some of those words and experiences later on as you engage with part 2. Kind of the second step in this is that students watch a short video that describes this. You are what you eat. Obviously, in this space, like pretty comfortable with what that phrase means. With your students, it'd be interesting to hear what they had to say and what comes out. And so there's a short video here that describes, and I'll skip the video just in the interest of time, but it describes you are what you eat. Your cells, you lose a lot of cells every day. Those cells are replaced, and it's those molecules that you get from your food, those ingredients that you get from your food that help in those cell functions, like you've all made clear in the chat. And so these are some of the questions that your students would be asked to consider and discuss after watching a short clip here. And what's the relationship between the food you eat and the cells in your body? And do you think you could learn anything about a person's diet from studying their cells? And this is really a critical question, because what we're trying to focus on here is ecologists in the Arctic are studying the cells of organisms to try to figure out what they're eating. So the idea here is we can connect to what students are eating, and that phrase, you are what you eat, we can bring that with us to the Arctic, and Arctic scientists are studying the cells of organisms to see what they're eating. And so in this case, we're really focused on a 2008 study in which ecologists traveled to Ukavik, Alaska, that's formerly Barrow, Alaska, so northern Alaska, to study Arctic feeding relationships and how they may change in the future due to rising temperatures and the dramatic decline in sea ice. So we're going to learn more about this study by reading the puzzle plots. So that is the segue into where you might hand out the worksheet, and the puzzle plot is that background text. So now we're going to read a little bit more about that 2008 study about the Arctic ecosystem, why the Arctic's warming, why sea ice is declining, and try to connect those important science ideas. So in this puzzle plot text, again, you could facilitate this by reading aloud as a whole class, by reading individually. If you had close reading strategies that you utilize in your classroom, now might be a good time to do that. But your job is to try to challenge students to connect science ideas from the reading back to that opening scenario. Again, trying to think about student experiences and applying them to a new investigation, and help having those experiences aid in the sense-making process. Students are asked to summarize key ideas by making a sketch and identifying the investigative question that scientists are seeking to answer. So a couple of different pieces in this identifying important science ideas step. This is a student-facing slide. We're going to learn more about the work being done by Arctic ecologists by reading that puzzle plot and asking students to circle the investigative question and underline similarities between the reading and the opening scenario. For our purposes here this evening, I think it's pretty important that we take 5 minutes right now and we all take some time to read through this puzzle plot text. I'm going to add the student worksheet to the chat right now. And I'll put up a 5-minute timer. We're going to watch the video here at the end together when you all come back, but take 5 minutes, read this text. We've spent a lot of time even today on this figure here. I'm not going to talk about it. I want to see what you all think. But I've tried to be really thoughtful about what the figures are, how they're included. So take 5 minutes, read through this, imagine how you might facilitate this reading with your students, what challenges might come up for you and for them. And we'll see you back here in 5 minutes.
Is it me, Jonathan, or did you just put up the timer instead of the
Ryan, you're right. I put up the timer rather than a task. There's no real task here. It's just to read that text and
I know, but I was reading. Where'd the text go?
The student worksheet text.
Yeah, there it is.
Oh, okay. I put a link to this in the chat. Can you see if you click on that link in the chat? It's a long docs.google.
Sorry, I was reading it on the link and I must have.
Oh, no worries.
Apologize.
No worries. Cool. And I'm going to stop this timer here and just head to this student worksheet real quick. So yeah, the goal here was just obviously everything's kind of rushed here, but wanted to give you an opportunity to read this puzzle plot, this background text to learn a little bit more about that 2008 study in which scientists are trying to figure out how the decline in sea ice might affect Arctic organisms large and small. So the Arctic is warming rapidly. We're seeing sea ice decline. Sea ice is a really important habitat, a characteristic of the Arctic habitat for a lot of organisms. In particular, these organisms, these algae that form the base of the Arctic food web. And so we've got two different types of algae that grows in sea ice, algae that grows in the open ocean. And we're satellite observations, we're seeing this growth in terms of population of ocean algae throughout the Arctic. And with sea ice algae, we're seeing a decline in sea ice algae in parts of the Arctic. So given that these two algae make up the base of the Arctic food web, like how might the increase in one and the decrease in other affect other parts of the Arctic food web? And to answer that question, we're going to use this biomarker, the fact that they make different types of carbon-based fats and that those fats can be traced through the Arctic food web. We're going to use that to help us answer that question, how other organisms may be affected by the change in algae population. So this is a little bit of a work in progress. We finished this figure about 2 hours ago. And it's been, it's trying to figure out how to best convey what I just articulated in a visual. And so for you, when you're facilitating this with students, we've got some stop and talks here, like might be a good idea to pause and as a whole class, talk through this diagram, because the goal here is to show again that these two algae, the base of this food web, and they pass their carbon-based fats on to zooplankton when the zooplankton consume the algae. Now you can see that there are different types of zooplankton. We're focused on copepods and amphipods. And the fact that copepods have more of these blue circles means that they're getting more carbon-based fats from ocean algae. The goal here is to say, they're eating more ocean algae, right? And if you look at amphipods are eating, they're more reliant on sea ice algae. If we follow through this little food web up to bowhead whales, you can see bowhead whales have more carbon-based fats produced from ocean algae. So we might predict that they're eating more copepods. The point here, right, is that bowhead whales and copepods seem to be more reliant on a food chain that starts with ocean algae. In a future with Mo or ocean algae, how might this food chain be affected? Maybe these organisms do better. Maybe organisms that are more reliant on sea ice algae fare a little worse, right? I'm kind of giving away far too much right now, but that's what we're trying to articulate through this visual. Wanted to just pause here and show the video that's included at the end, taken from the scientists up in Utkavik, Alaska, formerly Barrow. And again, hopefully this helps students and all of us better understand, where the numbers are coming from that we're going to be looking at here in just a few minutes.
Snacks, ice scoop or duct tape toolkit.
Cases packed? Check. Sled loaded? Check. Thermal pants on? Check. For this team of marine ecologists, it's time to hit the ice, and that means gunning it. It may be late spring, but it's a frigid ride out onto the sea ice off Barrow, Alaska. Desolate as it looks, the ice is actually teeming with life. With support from the National Science Foundation, Craig Aumack with Columbia University and a team have come here to study algae, microscopic aquatic organisms that form the very base of the marine food web. Some even live in the ice itself, dormant all winter until the spring sunshine kickstarts a growth cycle.
They start to bloom, which implies that they are multiplying at an exponential rate. And then as the snow completely melts and they start getting lots and lots of light, they migrate down to the bottom of the ice and then eventually leave the ice into the water column.
Algae may not seem as sexy as, say, polar bears, but without the algae, nothing could live here.
We are trying to trace the algae that grow within the ice to the underlying marine systems. So what organisms are grazing on it? Do they prefer it over algae that grow in the water column? And then how much do the organisms that live on the seafloor graze the algae once it's there?
They drill ice cores to measure algae levels and collect tiny algae eaters like these from the water and underlying mud. They drop underwater cameras down under the ice.
Jelly!
On the day we were there,
Jelly!
They netted this jellyfish. They'd seen them before with their cameras, but this is the first one they've hauled up from under the ice.
So it was like, wow, our jellyfish even adapted to swim so close to the bottom and drag their oral tentacles because they're feeding on the algae that collect along the bottom during this time of year.
Back in the lab, they run tests to see what kinds of algae the critters harvested on the ice have been eating. Going forward, the changing climate could mean less snow cover on the ice earlier in the spring, and that could mean disruptions to the food chain's delicate balance.
If you have a year when there's not very much snow, then there'll be more light early on, you'll get an early bloom.
Marine biologist Andy Jewell has done field work in Alaska since 2005. He says climate change likely will alter this habitat in ways we can't predict.
Large marine animals, seals and beluga whales and bowhead whales, the polar bears, all of those organisms are here because it is an incredibly productive environment. Typically, there's a long line of connections until you get to big animals. The entire food chain ultimately rests upon the algae.
Aumack says the algae could be considered a canary in the coal mine for climate change in the Arctic, early sentinels of a changing ecosystem.
So hopefully, like through that reading and through some stop and talks where you're talking about the visuals embedded in there in that video, right, we can start to identify some of these important science ideas. What question are the scientists trying to investigate? What do we know about these two different types of algae and how they move through the Arctic food web? What is a food web, right? So we've got some different things that you as the facilitator can talk about as needed, right? Depending on where your students are at in all of this. And so after reading that text and watching that video, it's really important for you, the facilitator, to come back to this slide deck and help students make the connection between what they are reading and that opening scenario, their experiences, right? So we won't answer this question together, but these are the prompts that are embedded in the slide deck. What What can measuring the amount and type of carbon-based fats in Arctic organisms tell scientists about what they're eating? So having students, maybe this is a think, pair, share, a shoulder partner, or something that you do with a whiteboard, but thinking about like, what do we know about these carbon-based fats and how they move through a food web? And then help them relate back to that opening scenario. Do you think a doctor could study the different kinds of fats that are contained within you and predict what you're eating? You know, maybe we talk about saturated and unsaturated fats that students are consuming and what that means for cholesterol. You know, like you could be creative and utilize what students have to say to make the connection between what they're eating and how we could go about studying that and what is happening in the Arctic. After you help students make the connection between that text and that opening scenario, we're going to go back to that student worksheet and ask them to identify an important idea. In this case, they're going to be constructing a food chain. That's practice for later on when they make their final models. They're essentially going to be making a food web. And so by having them make a food chain now, that's practice for later on. Just pull out the investigative question and then make a prediction for the investigative question. And so if we look at an answer key here, after that puzzle plot text, right, here's the question where they're going to have to construct a food chain, and there's a food web in the puzzle plot text. So that's what they would use to create their food chain. Here are two food chains that they could potentially make. They're going to describe how those carbon-based fats could be transferred to other organisms, identify this investigative question, and then make a prediction about the investigative question. So we tried to really help students here, you know, make sure it's clear that declining sea ice is changing algae populations. And how might those change in algae populations affect other organisms, right? And so having students identify a question, make a prediction, and then we're going to go into that data analysis piece. I think in the interest of time, we'll kind of just dive right into the data analysis piece. Know that there are some slides and strategies to help students make sense of the data set before you have them ask questions. So things like, you know, what do the different colors represent? And how do we know if one organism is getting more of their carbon-based fats from sea ice algae, right? So challenging them to talk about what they see before they go write about it. So in this case, scientists were able to gather tissue samples from these different organisms and determine their relative amount of carbon-based fats from sea ice algae and ocean algae. And so you can see that organisms that have a higher percentage of blue showing up of carbon-based fats, those are the organisms that are going to be more reliant on a food chain that starts with sea ice algae. Organisms that have more of that orange, higher percentage of carbon-based fats from ocean algae, they're going to be more reliant on a food chain that starts with ocean algae. And so by looking at these pie charts, right, we can have students start to think about, okay, if we have more ocean algae, how are organisms going to be impacted? If we have less sea ice algae, how might organisms be impacted? Start to make those predictions. So the questions ask students to do just that. So really trying to focus students on, you know, which animals get more carbon-based fats from sea ice algae, then have them make a food chain that incorporates those animals. Consider how a decrease in sea ice algae might affect the animals that are included in that food chain. So really trying to scaffold it. We do the same thing for the ocean algae. Which animals are more reliant on ocean algae? Let's make a food chain that represents the relationship between those organisms. How might an increase in ocean algae affect the organisms that you included in that food chain? And then ask students to revisit their prediction. And so this is that sense making, supporting ongoing changes in sense making. kind of bouncing around here. Probably shouldn't be doing that, but this data analysis piece really is that part 3 where students are testing their predictions against authentic data that we just looked at. So wanting you, the facilitator, to start by talking about the graphs, depending on what you do like to do in your classroom, having students work individually in pairs. I know some people like to use the WIS-WIM strategy, what I see, what I mean, that BCBS advocates for. So kind of, you know, we've got some different strategies here, but know that you all are the experts in the classroom and you know your students and you have your routines. And so want to encourage you to lean in on that as well. So I'm going to kind of skip ahead here. We've already looked at these pie charts and we've gone through questions 4 through 11. And the last piece here, the last ambitious science teaching practice embedded in this resource is like to put it all together and to construct an evidence-based explanation. And so this is where students are finalizing new understandings, science ideas as they relate to that investigative question. How might the decline in sea ice affect Arctic organisms large and small, to construct explanatory models? So you can have your students construct these models individually or in pairs. That's up to you. In talking a lot about this with Melissa and other piloting teachers, we have added options to create things like gotta have it checklists. These are co-constructed lists of important science ideas that need to be in final models. You don't need to make a gotta have it checklist every time you do a data puzzle. It's only if there's disagreement amongst students about what should go in there. And then it's really important to, lean into that disagreement. Why do you say this? Why do you say that? Do you agree with this? What evidence do you have for this? And then you can start to put those ideas on this gotta have it checklist. Once ideas are thrown out there with students, only ideas that are agreed upon amongst everyone go up on that gotta have it checklist. And so the idea is to help students produce those models that can be challenging at times. So we've got slides in the slide decks. They're hidden. So they're currently skipped in the slide deck. So if you were in presenter view facilitating this for students, you wouldn't see the gotta have it checklist slide unless you unhid it. You didn't skip it. So just know that those instructions are in there, but didn't want to force you to do that. Again, that's only if there's some disagreement. We've got a slide 2 of signs and symbols that could help students with modeling conventions, arrows, text boxes, those sorts of things as well. So again, those of you that have worked with me, right, we want to describe what a final model could look like, what a scientific model is, what should go in a scientific model, relevant parts, connection between parts, what evidence do you have? And we can use this Black Panther example that I always use. Feel free to change that out if you're utilizing my slide decks and you want some other Marvel movie. But the goal here being for students to identify these different components in a model to help them visualize what their model could look like. And then we're asking them to make their own models, thinking about parts, connections, evidence for the investigative question. So all that said, right, tons of information with the puzzle plot. We've got some different videos showing temperatures warming, sea ice declining. We've got these complex graphics that show the flow of carbon-based fats. We're talking about food webs. So there's a lot here. Here's an example of what a final model could look like. And again, your students have a graphic. I'll go to the student worksheet here in just a moment that they're going to annotate with arrows and text. And so in this case, these arrows mean different things. This is what a gotta have checklist could be useful for, talking about modeling conventions and what different color arrows could mean. In this case, blue is passage of time, white is direction in terms of population, and red is showing the flow of energy. So we see this food chain from ocean algae to zooplankton to bowhead whales, and those populations he's predicting are increasing with the decline in sea ice. Whereas a food chain connected to sea ice algae, we might see those populations decline. We don't know for sure, but that's what we're predicting based on the data that we have. Moving forward, after students construct those final models, wanting to add a digging deeper question. So each data puzzle has this. After students construct their final model, want to have them think about something, whether it's solution-based or social justice-based. In this case, thinking about Arctic indigenous peoples, which, really, in their food webs, humans are in the Arctic food webs. They are a part of the ecosystem. It's in Western society that we remove ourselves. And so wanting to think about, okay, let's put people into this food web and how might the decline affect these indigenous people, and start a conversation there, and support that with a video that we embed at the end of the slide deck. So that's the product. And so if we look at the data puzzle, right, there's the data analysis piece, there's the final model construction. Here's the image that they would annotate. I think I'll probably swap this out with a black and white image for students. And then there's that digging deeper question that students would answer. So again, as you, the facilitator, you're going back and forth between the slide deck for those discussion and talk moves, and then students are moving into the student worksheet to do different tasks. So I think that's one of the challenges that I need to also, we'll be working with anyone that's interested to try to figure out. It's like, how do I make it clear when teachers are in the slide deck going back to the student worksheet, right? Those talk moves that are really important to help students make sense of this question here. How might the decline in sea ice affect different organisms? That is an insane amount of information to throw at you in an hour. I can't imagine watching this webinar and getting all of that later, those poor folks. But if you wanted to do this in your classroom this spring, once these gift cards get approved, again, I know there are some people in here that I owe money to, but I'm going to make some more promises nonetheless. If you're interested, please complete that Google form. I think I just put it in the chat, just your name, your email, whether you'd be able to do this spring, and I'll reach out to you to talk more about what that would look like. It's just a survey. Those of you like Matt that are piloting a different unit of mine right now, that's a little bit more involved, and there's going to be an interview. You got to meet with me on Zoom and answer some tough questions. But in this case, it's just a survey to try to figure out your experience and how this resource can be approved. Also going to make a pitch for some of the other data puzzles that I've got. I will say that the framework is the same across all of the data puzzles. Obviously, the content is different. So adding a link to this data puzzles webinar series, from that link, you should be able to sign up for the 3 other webinars. Join me St. Patrick's Day next week for the tipping point, if you want to spend another Thursday with me. But we'll record each of these, so you could watch them. But if you attend this and you get that structure down and that framework down, like you hopefully you can just go into these other resources and understand what you're supposed to do. Some other things, excited to start promoting my summer PD. So this whole story is like one lesson in this changing Arctic ecosystem unit that I've got and need to clean up a little bit for the summer PD. But this summer PD has some story maps. It's got more data, more hands-on investigations to help students understand how the decline in sea ice is going to affect organisms large and small. So there's much more to this story that you just engaged with tonight, and we'll dive into that July 27th, 28th. I'm going to send an email out in that Eventbrite that has these opportunities if you're interested, but wanted to just promote this. If you attend this, you get 10 hours of PD, and in this case, you have to purchase the grad credit from CU Boulder if you want, right? That's optional. Also running a different unit I wrote called The Future of Forests that explores shifts in post-fire succession patterns in a changing climate. And so again, those of you that have worked with me in the past, you know my style and what that unit, kind of that structure looks like. So The Future of Forests is another one. These dates may change, but you know, if they do change, I obviously would let you know should you register. So same deal, 10 hours of PD, option to purchase a credit for $80. So we got data puzzles, we got Arctic ecosystem PD, we got forest fire PD, and I'm going on paternity leave in 2 weeks, so I'll still respond a little bit, but won't be as quick. So that's the story, and I'm sticking to it. Anybody have any? I'll check out the chat here. I fell behind a little bit. Thanks. Congratulations. Awesome. Thanks, guys. Yeah. Hopefully she's in bed right now. That's it for this evening. Happy to hang out and answer questions. Happy to post some more of those links in the chat if people want to see those, but I'll send out an email that has all those links. Thanks, team.
Thank you.
Appreciate you all sticking with me. It's really nice to see familiar faces. I love it.
Thanks, John.
See y'all. See you, Matt. Be in touch.
Thank you.
Yeah, you bet.
Thanks, John. I know this is
Ann.
great. I will be
Appreciate
using
it.
it very soon.
Awesome.
I have a quick question for you.
Yeah, Gina.
So, could we get a certificate or anything to show the 1 hour? I know it's not very much, many hours, but
Let me see if I can. I'm going to pause.